Hello students and welcome to the lecture. So students, as we know that in the previous lecture we had started our discussion over the topic of motion. We had covered several facts and figures regarding the same because that was our part 1 and this is, as you can see, our part 2. Okay. I hope you have revised the previous lecture in the well enough manner before you have come for this lecture. As many times I told you, it is for your own benefit. In this lecture, basically what we are going to do, we are going to talk about the scalars and vectors, distance and displacement, acceleration and retardation, and the summary at last. Okay. But before starting this, there is a small disclaimer presented over here. And the disclaimer is like, the images used in a slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this track and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Now, let's begin with the scalars and vectors. So what do we mean by this? First, scalar. The physical quantities which have only magnitude but no direction are called scalar quantities or scalars. Like you can say, they have only magnitude, they could move, but not in any particular direction because they do not have any direction. That's why we call them as scalars. Okay. Like here, if you look at this picture, you can say 5 meters long. What is this? You are only seeing the magnitude, but this 5 meters long is in which direction? North, south, east, west, northeast, northwest, southwest, southeast. Are you getting these directions? No, you are only getting the magnitude. For example, the mass, length, time, distance, speed, work, etc. These are the scalars because they only have the magnitude, they do not have any specific direction. Now, vectors. These are the physical quantities which having the magnitude as well as direction. That's why these are called the vector quantities or vector. Now, you can see, this is the vector. You are getting the magnitude of 5 meters plus direction also. 5 meters east. Okay. You are getting a particular direction. That's why this is the basic difference between the scalars and the vector. In scalars, you only get the magnitude. Here you can see in this picture, 5 meters long. But in which direction you are not getting any specific data related to this. On the contrary, you are getting vector 5 meters east. Here you are getting the magnitude as well as the direction in which this magnitude is. For example, displacement, velocity, acceleration, force, torque, gravitational intensity, etc. These all are the examples of vector. Now, if we talk about the list of scalars and vectors, we could say first we have the scalars. In scalars, we have mass, length, time, distance, speed, work, energy, volume, density, power, pressure, electric potential, gravitational potential, magnetic potential, resistance, electric. In vector, we have weight, displacement, velocity, acceleration, force, torque, electric field, gravitational intensity, momentum, impulse, dipole moment, current density, temperature gradient. Okay. So this is the list of scalars and vectors. You could have it. Now, what is the difference between the distance and displacement? That is what we require to understand actually when we are talking about the motion. Because in the previous one, when we were talking about the motion, we had seen that there are static motion and there is a other kind of motion. Okay. In the rest position, basically an object is not changing its position in reference to the space. Okay. But in the motion, the object is changing its position in reference to the space. That what we had discussed in detail. So I'm not going to start this over here. But what I'm trying to say, like we had discussed, and when we are talking about the motion further right now in this lecture, so it's become essential for us that we must understand what is distance and what is displacement. Like many times you have heard these terms whenever you're talking about any moving object. Distance, displacement, like how much distance it has covered, how much displacement it has covered. They both are related with the motion. So they both should be same, right? That what's come in our mind. But that is not in reality. The reality is somewhat different. Okay. And if we really want to understand it, we must understand it with some scientific facts. Distance first. The length of the path traversed by a body is called the distance traveled by. Like here, if you look at this picture, they are the 2 points, A and B. Okay. So here you can say the A covered this distance to reach B. Distance is 9 meters, right? So this is the length of the path. How much path have been covered by A? 9 meters. The path may not be straight. Okay. Like here you can say this path is not straight. This path is zigzag. Okay. And distance is a scalar quantity. Why? Because it do not have any kind of particular direction. Like here you can say first it go to the north, then east, then northeast, then again east, then towards the southeast, somewhat we could say, then towards again the southeast, south and southeast. So here you can say, is there any particular direction the path is being followed? No, the path do not having any kind of particular direction. And we know when there is only magnitude but not having any direction associated with this, it will always be a scalar quantity. So that's why distance is a scalar quantity. Now I hope you understood why. The SI unit of distance is meter, m, and CGS unit is cm. SI means in the international standards of measurement, we measure the distance by meters. In the CGS system, like centimeter, gram, and second, we measure the distance by the centimeter. Here, if it is written down 9 meters, what do you think? In which unit we had measured it? In the SI unit. Got it? If it would be 9 centimeter, then what it would be? It would be a CGS unit. Okay. Now the displacement. The shortest distance from the initial to the final position of the body is called the magnitude of displacement. Okay. Like you can say in the displacement, in the distance, we are talking about the total length. Okay. We were talking about the total length. In displacement, we are talking about the shortest distance. Okay. From the initial to the final position. From the initial to the final position. Like this is A. Okay. Now you can say it is the initial position or original position. When you had gone there. Okay. So that will be your final position. So the shortest distance that you have covered, shortest path that you have covered was 4 meters. Right. So that will be your displacement. It is the direction from the initial position to the final position. It is a vector quantity. Why? Why it is a vector quantity? Because when we were talking about the distance, we said that there was no specific direction associated with the path. If you look at here, what you are seeing, you had started traveling in east. So you can say there is a particular direction attached to your traveling. Okay. That's why it is the vector quantity, and that's why it's a direction from initial position to the final position. Like you had started moving towards east and you reach your final position in east. So there is a specific direction. The SI unit of displacement is m, and in CGS the unit is centimeter. Okay, similar like the distance. There is a note: the displacement of an object in motion could be positive, zero, or negative. Remember this. The displacement of an object in motion could be positive, could be zero, could be negative. Okay. The difference between distance and displacement. Now, if we talk about it, so serial numbers, distance, and displacement. First is distance. By definition, we could say it is actual path traversed by the object in the given time. Like here you can say, if we said 9 meters have been covered in 3 minutes. So this is the distance because there is the actual path that we talked about. There is no time associated with this. Thereafter, in displacement, it is the shortest distance between the initial and final position of the object in given time. Okay. Here we had just seen. It is a scalar quantity. Why? Because there is no specific direction associated with this. It is a vector quantity. Displacement. Why? Because here we had seen there is a specific direction associated with this. It is always positive. Remember, distance could not be negative. Okay, could not be zero. Displacement might be positive, zero, or negative. It's totally depending on the direction. It could be more than or equal to the magnitude of displacement. Its magnitude could be less than or equal to the distance, but could never be greater than the distance because it is always the shortest distance. Got it? It may not be zero even if displacement is zero. It is zero if distance is zero. Now the speed and velocity. These two terms also we often get confused somewhat, like what is the speed and what is the velocity, because they both are similar to each other when we talk about them, but they also are different from each other when we talk about them with the scientific point of view. Okay. So first, if we take the example of speed, what we could say, the speed of a body is the distance traveled by the body in a unit time interval. Therefore, it is the distance traveled by the body in 1 second. The speed of the body is the distance traveled by the body in unit time interval. Okay, that is it. It is also the scalar quantity because there we are not talking about any kind of specific direction associated with. Okay, it is generally represented by the letter U or V. If a body travels a distance s in time t, then its speed is v. Distance upon time. This is the formula you can say. If you ever have to calculate the speed, you can say distance upon time. For example, if the body covered 100 meter in 10 seconds. Okay, so what you can say, how much is the speed? 100 by time, 10 meter per second is the speed. Okay, the SI unit of speed in meter per second is ms, and CGS unit is centimeters per second. Like you can say, because we measure distance in meter and second in s in the international standards. Similarly, we measure the distance in centimeter and time in seconds in the CGS unit. So that's why in SI unit, if you calculate the speed, the SI unit of speed will be meter per second. In CGS unit, that will be a centimeter per second. Uniform speed. A body is said to be moving with uniform speed if it covers equal distance in equal intervals of time throughout its motion. Okay, then it is the uniform speed, equal distance in equal intervals of time throughout its motion. Okay, like in 1 second, if the body had started the traveling, in 1 second that was covering the 10 meters. Okay, for example only. Then it had to cover 100 meters and it maintained its speed, like covering the 10 meters in 1 second. So that will be a uniform speed because the distance traveling and the time taking is equal to each other since the starting till end. If a body moves with the uniform speed v, the distance traveled by it in time t is as equal to v into t. Okay. Non-uniform or variable speed. A body said to move with non-uniform or variable speed if it covers unequal distance in the same intervals of time. Like for instantly it starting covering the 50 meters in 1 minute. Thereafter they covering 100 meters in 1 minute. Thereafter 150 meters in 2 minutes and all. Now you can say that the distance covering and the time taking, they both are different. Okay. Then that will be a non-uniform or variable speed. Thereafter, the instantaneous speed. If the speed of a body keeps on changing continuously with time, okay, its speed at any constants is known as the instantaneous speed. Like you can say, when the body started traveling, it was covering 20 meters in 1 minute, then 30 meters in 1 minute, then 50, 60 meters in 1.5 and 2 minutes and all. Now you can say that its speed is continuously changing or keep on changing with the time. So the speed at an instant is known as the instantaneous speed. Okay. The speedometer of vehicles measures the instantaneous speed. Now what is the average speed? The ratio of total distance traveled by the body to the total time of journey is called the average speed. Average speed is total distance traveled by total time taken. Like for example, if a body covered 100 meter in 10 seconds, then 10 meter per second was the average speed. Okay, because total distance covered is 100 meter, total time taken 10 seconds, 100 by 10. When you will solve this equation, you will get 10 meters per second is the average speed. In a case of body moving with uniform speed, the instantaneous speed and the average speed are equal. Okay. If a particle travel distance s1, s2, s3, etc. with speeds v1, v2 and v3, etc. respectively in same direction, then total distance travel will be s1 plus s2 plus s3 plus so on, will be in the continuous form. Average speed will be v equal to av equal to s1 plus s2 plus s3 plus so on upon s1 upon v1 plus s2 upon v2 plus so on. So that will be the average speed formula if it is covering the different speeds and different. If s1 is equal to s2, then s2 will be equals to s. Therefore, the body covers equal distances with different speeds, then VAB is equal to 2s upon 2 bracket 1 by V1 plus 1 by V2 is equal to 2V1 V2 by 2V1 plus V2. It means average speed is equal to the harmonic mean of individual speeds. If a particle travels with speeds V1, V2, V3, etc. during time intervals of T1, T2, T3, etc. respectively, then the total distance traveled will be V1 T1 plus V2 T2 plus V3 T1, T3 plus so on. So average speed will be VAV is equal to V1 T1 plus V2 T2 plus V3 T3 plus so on, and upon T1 plus T2 plus T3 plus so on. If T1 equal to T2 and T2 equal to T3, then that will be continue till Tn is equal to T. Then V and V is equal to bracket V1 plus V2 plus V3 plus so on Vn, then multiply by T upon Nt equal to V1 plus V2 plus V3 Vn and n's power n. It means average speed is equal to the arithmetic mean of individual speeds. Okay. There is a note. If a particle moves for two equal intervals of time of different speeds, then wave is equal to v1 plus v2 by 2. If a particle moves a distance at speed v1 and comes back with speed v2, then v dv is equal to 2v1 into v2 plus, upon v1 plus v2. Now velocity. What is the velocity? We have taken the consideration on speed. Now it's part for the velocity. The rate of change of displacement with time is called then velocity. Therefore, it is the displacement of the body in 1 second. So now we are not taking the consideration of distance. We are taking the consideration of displacement in 1 second. It is the vector quantity, because when the displacement is there, we know the displacement associated with the specific direction. So that's why when the direction involves, it is a vector quantity. Represented by the symbol, this one. For velocity, both its magnitude and direction must be known. Then only you would be able to calculate the velocity. The SI unit of velocity is also the meter per second, but -1, and CGS unit is centimeter per second minus. Now, what is a uniform velocity? If a body travels equal distances in equal intervals of time along a particular direction, the body is said to be moving with a uniform velocity. If a body moves with uniform velocity, the displacement s of the body in a time interval t is given as equal to vt. Now the non-uniform or variable velocity. If a body moves unequal distances in a particular direction in equal intervals of time, or it moves equal distances in equal intervals of time, but its direction of motion does not remain the same, then the velocity of the body is said to be variable or non-uniform. For example, the motion of a body in a circular path with uniform speed is with variable velocity, because in circular path, the direction of motion of the body changes continuously with time. In case of motion with non-uniform velocity, we specify the instantaneous velocity and the average velocity of the body. Now, what is the instantaneous velocity? For a body moving with variable velocity, the velocity of the body at an instance is called instantaneous velocity. What is the average velocity? If the velocity of a body moving in a particular direction changes with time, the ratio of displacement to the time taken for the whole journey is called the average velocity. Thus, average velocity is equal to displacement by total time taken. Difference between the speed and velocity we talk about. So first, the speed is the distance traveled by a moving object in 1 second is called speed. For velocity, the distance traveled by a moving object in 1 second in a particular direction is called its velocity. It is a scalar quantity, speed. It is a vector quantity, velocity. The speed is always positive because the velocity is depending on the, you can say, direction of motion. So that could be positive or negative. Speed in one round in a circular path, the average speed is not zero. In one round in a circular path, the average velocity is zero. Now the acceleration and retardation. If we talk about them, what is the acceleration? The rate of change of velocity with time is called the acceleration of the body. Okay. Like acceleration is equal to change in velocity by time, or a is equal to v minus u by t, or v is equal to u plus at. Acceleration is also the vector quantity because it is associated with some particular direction because velocity is involved. Okay. It is represented by the symbol, and the direction of acceleration is the direction which the velocity changes. The SI unit of acceleration is meter second minus 2, and CGS unit is centimeter seconds minus 2. The acceleration does not determine its direction of motion. The positive or negative sign of acceleration simply tells us whether the velocity is increasing or decreasing A with time, whereas positive or negative sign of velocity depend on its direction of motion. There is a note. Mathematically, A is equal to this that you can see over here. If a body moves with constant velocity, then A is equal to this. Thus, in uniform motion, acceleration does not exist. Okay? Uniform acceleration. The acceleration is said to be uniform or constant when equal changes in velocity takes place in equal intervals of time. The motion of a body under gravity is an example of uniformly accelerated motion because the change in velocity is equal to the changing intervals of time. Variable acceleration. If the change in velocity is not the same in the same intervals of time, the acceleration is said to be the variable because there is no equality right now. Acceleration due to the gravity. When a body falls freely under the gravity, the acceleration produced in the body due to the Earth's gravitational attraction is called the acceleration due to gravity. It is generally denoted by a letter g. If a body falls down, its velocity increases with time, so the acceleration is plus g or positive g. While if a body moves vertically upwards, its velocity decreases with time, so the acceleration is negative g or minus g. The average value of g is 9.8 meter second square or nearby 10 meters squared minus 2. Actually, it varies from place to place. Thus, if a body falls freely under gravity, its velocity increases at a rate of 9.8 meters second square. Therefore, starting from rest, after 1 second, the velocity will be 9.8 meters seconds per square. After 2 seconds, the velocity will be 2 into 9.8 equal to 19.6 meters second per square, and so on. That will be continued. Similarly, if a body is projected vertically upward, its velocity will be decreases at a rate of 9.8 meters second square. Therefore, if a body is projected vertically upward with the initial velocity of 49 meters per second square, after 1 second, its velocity will be 39.2 meters second square. After 2 seconds, its velocity will be 29.4 meters second square, and so on. It may be noted that the value of g does not depend on the mass of the body. Hence, if two bodies of different masses are simultaneously dropped from a height, body will reach the ground simultaneously if the effect of air, like the friction and the buoyancy due to air, is neglected. Retardation. If the velocity of the body decreases with the time, the motion is said to be decelerated or retarded. Thus, retardation is the negative acceleration. In general, acceleration is taken positive while retardation is taken negative. Equations of uniformly accelerated motion. There are the following equations for the motion of a body moving with a uniform acceleration, which give the relationship between the initial velocity, final velocity, acceleration, time of journey, and the distance traveled. Like v is equal to u plus at, as equal to 1 by 2 into u plus v into t is equal to ut plus 1 by 2 at square. V square equal to u square plus 2as. Sn is equal to u plus 1 by 2a into 2n minus 1, where Sn is equal to distance traveled by the body in n seconds. Equation of motion of the freely falling body. The motion of a freely falling body from a height or the motion of a body thrown vertically upwards from the surface of the earth is one-dimensional motion under the gravity. The acceleration of vertically falling body is a is equal to plus g, and retardation of a body going vertically up is a equals to minus g. For a body falling down from the height h, initially rest equal to u is equal to 0. Equation of motion are v equals to gt, h equal to minus 1 by gt square, v square is equal to 2gh. Similarly, for a body thrown vertically upwards from the earth's surface with initial velocity u, the equation of motion are v is equal to u minus gt, h equal to ut minus 1 by 2 gt square, v square is equal to u square minus 2gh. At the highest point, v is equal to 0. T is equal to ug and h max is equal to u square by 2g. Now it's part for the summary discussion because we have finished the topic. We have talked about the detailed explanation of various fundamental concepts in physics related to motion and forces. Distinguishing between scalar and vector quantities, providing examples of each. Scalars have only magnitude, like we had discussed, mass, length, time, while vectors have magnitude and direction, like the displacement, velocity, and force. Key concept: distance and displacement we have discussed, speed and velocity we have discussed. Acceleration we have discussed, retardation we have discussed, equations of motion we have discussed, and with this we have finished this part. It is requested to all of you kindly revise the facts and figures that all we have discussed in this lecture and keep yourself ready for the next lecture. With this note, let's end this lecture and